This is chapter 5.3, Logarithmic Functions and Graph Notes, part 4. If you haven't watched parts 1 through 3, please go back and do that. We talked about earlier that there are a couple of logarithms that are very helpful and useful and popular. One of them was the common logarithm, right? And that was log base 10 of x, which they just wrote log of x. Now, last section, we talked about Euler's number E. Euler's number, remember, e to the first power is 2.71828182884. But Euler's number is a very useful log as a base. So a lot of the times we, instead of writing log base e of x, what they call that, this is called the natural log, which is ln of x. This is the natural logarithm. This is used enough that they have an actual button for it on the calculator as well, and it's right next to the LOG button. So instead of writing LOG base E of 53, what we will do is just write ln of 53. Those are equivalent functions, which we will talk about a little bit more later. This example says, find each of the following natural logarithms on a calculator round to 4 decimal places. So here's my calculator. We will look for the ln button. It's right beneath the LOG button. It's right next to the number 4 on your calculator. Now, I want to point out that 10 to the x and LOG are right next to each other because they're inverses. E to the x and ln are right next to each other because they're inverses. So I just wanted to point that out to you here. So let's type in ln of 645,778. Close your parentheses because they opened it. And there is your decimal, 13.3782. Now let's look at the 2. The one right next to it is a 1, does not round it up. So this is indeed 3782. Now I wanted to point out to you earlier we did the same thing with LOG base 10, not base E, of 645,778. And closed our parentheses. These are not the same thing. The LOG is log base 10 and the ln or LOG base E are not the same thing. So we will be using them interchangeably when we solve equations, but they're not the same function. So again, number 13 says find the ln of 0.000040239. Close my parentheses. This is a negative 10.641. The 3 does not round the 6 up. So there's a 6 at the end. Number 14 says ln of negative 5. Ooh, that gave me answer. This is non-real answer. There's an error here. Now I'm going to come back here, and when we talk about the log or the natural log, the graphs look like this. So the x values don't exist in the negative part of our domain, our x's. They don't exist. So if you get an error, non-real answer, double check that you put it in right. But this is a no solution. Because remember that the argument, this is still called the argument, must be positive. The argument must be positive. Super important, can't forget it. Now, let's go ahead and put number 15 says ln of e. Now, we just talked about that ln and e are inverses. Now, eventually, what that's going to mean is that they're going to cancel each other out. But let's clear this and go ln. Now, I'm not going to use this e because I don't want to have a power. I'm going to use this e because it doesn't have a power. So ln of second e. Close my parentheses. It cancels and just gives you 1. ln of e is 1. Number 16 is your turn. Go ahead and do that on your own. Now we're going to look at change of base formula and how to put things with a base of not 10 in your calculator. So we talked about how to put something like this, log of 5 in your calculator, but if it had a base of 2, you couldn't put that in your calculator so far. So what we're going to do is use the change of base formula to put these things in your calculator. So the first thing we got to know is that your m has to be greater than or equal to 0, and b has to be greater than or equal to 0. And by the way, the reason we want to put this in our calculator is this says 2 to what power equals 5. We don't actually know that. It's going to be a decimal. 2 to no power is 5. So that's why we would want to put these things in our calculators. Now, before they had these big old giant tables for us to use, but we need to use the change of base formula to either use the tables or to use the calculator. So the change of base formula says this: log base b of m equals log base a of m over log base a of b. This says that you can choose whatever base you want for a. Now what we're going to do is we're going to choose a equals 10 every single time so we can put it in the calculator. So this is the same thing as log of m, understood base 10, divided by log of b. So really all you do is the log of the argument divided by the log of the base. So let's look at number 17. Again, we can't put this in our calculator. You can't just put log of 8 in your calculator because it misses the base of 5. So what you do is you put log base 10, understood base 10, of the argument 8, divide by log base 10 of the base 5. And now we're going to put this in our calculator, and we'll round to 3 decimal places. Here's our calculator. So if you want to, you can do alpha y equals 1 to give yourself a fraction bar. I would suggest this. Log of 8, close your parentheses, arrow down, divided by log of 5, close your parentheses. Hit enter. 1. So this is approximately equal to 1.2920. The 2 does not round the 0 up. So if you want to have that 4th decimal place, there's the 4th decimal place. Number 18, log base 3 of 15. Again, you can't put this in your calculator, so you need the change of base formula to be able to evaluate it, because we don't know. What power is it do you round 3 to? You raise 3 to get 15. 3 to what power is 15? 3 to the 5th is not 15. 3 times 5 is 15. So you would do log of the argument, 15, divided by log of the base, 3. So the other way that you can do this without using the fraction bars, you would do log of 15, but you must close the parentheses. If you don't, it will be wrong. Divide by log of 3, close your parentheses. This gives you approximately equal to 2.46497. The 7 will round the 49 up to a 50. So this is 2.465. If you need the 0, you can put the 0 as well. One more example, then it's your turn. Log base 4 of 12. So log of the argument 12 divided by log of the base 4. You cannot reduce the 12 and the 4. You can't do this. Again, the reason why we're doing this is because it asks us 4 to what power equals 12? I don't know, 4 to no power, because 4 squared is 16. So it should be in between 1 and 2. So log of 12 divided by log of 4. Again, do not touch the 12 and the 4. You cannot reduce those. This gives me 1.792. The 8 rounds the 4 up to a 5. Your turn. Now I want to stress here, if you have any questions, if you have problems with MyMathLab, don't understand how to put it in, don't fall back on well, nobody knows how to do it, so I can't get help. Please text me, email me. I will Zoom individually with you when you have questions. So please don't just give up. we're all in this together. I'm here for you. Please ask me questions. I love to hear from you guys.